compare a square root and a cube root. Square roots, square root of 0 is 0, with only real numbers. Square root of 1 is 1, square root of 4 is 2. Square roots are only going to provide answers that are greater than or equal to 0. But with cube roots, you still get 0, and you get 1. And like for instance, you get 2, but you also can go the opposite way. What is the cube root of -1? And that means what times itself 3 times gives you -1. And what is the cube root of -8? So instead of only going in one direction, it's going to go in 2 directions. It will represent answers that have a positive x's, x is equal to 0, and x is equal to a negative value. Okay? So if you look up here, give me 1 second here. I'm going to pull this Desmos up so you can see it. So if I change this and it says y equals, and I'm going to change it to x raised to the 1/3 power. So that's what it's going to look like. It can represent when x's are positive, when x is 0, or when x's are negative. Watch this. If I take and put a +2 in there, which direction do you think it's going to go? Right or left? Left. +10, left 10. If I switch it and make it a -10, it goes to the right. Same concepts. Now what if I put those numbers in back? Like if I put a +2, which way is it going? Up to a -5 or -6 goes down. Watch the stretch. This is a vertical stretch. See how it pulls it? It stretches it. It compresses it if the number is smaller. If it's smaller than 1. So see how that's almost flat? Sorry, I put 2 periods there. See how it's almost flat? The compress and the stretch. Okay, coming back. Here we go. On your calculator, we're going to talk about this. We know that this is the parent function, so let's start with our NAs. Please put 0 in the very middle this time. These will represent good points for the parent function of a cube root function. So when you plug in 1 for x, you get an answer of 1 like we spoke about. When you plug in 8, you get an answer of 2. 0, 0, 1, 1, and 8, 2. For those that did not understand that, looking at Desmos, what is the cube root of 1 again? 1. What is the cube root of 8? 2. Now I'm going to plug in -1 and -8. And there are values like -2 and -3 that you can get from a calculator, but the answers are irrational. They're not pretty to graph. So the cube root of -1 is -1, and the cube root of -8 is -2. The domain. Domain runs from left to right, So it goes from -infinity to +infinity. The range comes from the bottom top. Range runs from -infinity. This continues to go downward at a slower rate, and it continues to go upward at a slower rate. Always judge increase and decrease from left to right. So what's happening right now? It's increasing the whole way from left to right. For this particular problem, the next 3 are pretty easy. So where does the real 0 occur? It occurs where x is equal to 0. The x-intercepts and the y-intercepts are also at the origin. Okay, coming over here. For this function, as you go to the left, to -infinity, which way is this going? It's going down. And as you go to +infinity, which way is it going? It's going up. Now let's talk about how could you graph this without having to know some of those things. So go back here to y equals. In parentheses, put an x, raise it to the 1/3 power, and hit graph. do second table, you're not going to run into values that say error, because remember, we can plug in negative we can plug in negative numbers, positive, or 0. So move up and down here, and we're going to stop anywhere we see a nice number. So -8, 2. Okay, we've already graphed it. -1, 1. We've graphed it. 0, 0, 1, 1, and 8, 2 again. So for like dummies graphing, there's no problem using a calculator, okay? To understand the concept, either method works. Here's the concept of how do we get these numbers, but there's no problem with you using a calculator as a tool. Okay, we're going to come down to the next one. On your own in 30 seconds, you have 4 things to do. On your own, without talking to your partner, please predict, is there a reflection, a stretch, or compression, or is there any horizontal or vertical shifts? On your own, please, go ahead. Okay, I'm going to let you shout out for just the first couple, and then I'll call on people. Is there a reflection? No. Okay, tougher question. Kat, if there was a reflection, where would you find it? If there's a negative right here. Good. There's no reflection. Don't leave it blank. Put an NA. Vicky, is there any stretches?
No.
Compression?
No.
Where would you find it if it did occur? In the outside. Good. Frederico, is there any horizontal shifts? Yes. Which way? Up 2. Do you agree with that? Right. Good. Okay, good. Right 2 units. Pablo, is there any vertical shifts? Down 5 units. So go right 2 and down 5, please. 1, 2, 3, 4, 5. There's no problem with using a calculator, but I'm going to go through and I'm going to use this pattern. But there's no problem with you using a calculator. So the pattern is 0, 0, 1, 1. Now I'm going to count 8 to the right. 1, 2, 3, 4, 5, 6, 7, 8, and I'm going to go up 2. Then the pattern is -1, -1. This is like your origin. -1, -1, and then -8, -2. 1, 2, 3, 4, 5, 6, 7, 8, and down 2. In case you were confused as you graph that, I'd like to show you what this looks like. So I'm going to insert in here an x minus 2 raised to the 1/3 minus 5. I'm going to give you a chance to plug this into your calculator. So if you're confused with how I came up with the points, remember your option is, after you plug this in, to do second graph and to look at the table of values. You're going to stop wherever you see a coordinate that has both an integer for the x and the y value and graph those points. You'll come up with the same graph. Domain continues to move to the left, never stopping, and continues to move to the right, never stopping. So negative infinity to positive infinity. Range from bottom to top. The range, it continues to move down and it continues to move up. From left to right, is this increasing or decreasing? From left to right. So an NA for decrease. When is the only time that we're going to change this into decreasing? Anybody have an idea? Nice job, Hector. When it reflects, this will go down and this will go up, okay? And then it will be decreasing. Okay, so it increases from negative infinity to positive infinity. Now, you ready? So where are the real zeros? This is what I prefer to do. I'm going to do mental math. Who can I challenge? Emma, you took off yesterday. Okay, ready, Emma? We're going to take and plug in a 0 for y, and you're going to do this mental math. You can do it. So if this is a 0, what's your first step in isolating the x? So now 0 plus 5 is 5. Got that? Now, Emma, I'm going to rewrite this for you so there's no confusion. That's what you've told me. 5 equals the cube root of x minus 2. How do you eliminate the 1/3, Emma? Which exponent do you raise it to? 3. So I'm going to raise this to a 3 to the 3rd power. And I'm going to raise this to the 3rd power. So now on the left you have an answer of, what's 5 cubed? 125. And your last step is to add 2, which gives you an answer of 127. That seems a little crazy, so we're going to check. Grab the graphing calculator. First thing is we have to extend that window far enough out that it will actually identify it. So I'm going to go past the 127. And then, by the way, just using common sense, I went all the way out to 130. Do you see how it crosses over just before that? Please do second, trace, value, and type in 127 just to check. Is her math correct? Yep. Okay, because we have y equals 0. Now when you want to find an x, or a y-intercept, x must be equal 0. So do second, trace, value, plug in 0 for x, and we're going to round to the nearest hundredth, negative 6.26, approximately. And behavior, as we go to the left, it continues to go downward, and as you go to the right, it continues to go upward. Flip your paper to the back, please.